Hello, this is OCR Further Statistics. We're in Discrete Random Variables 3 and the fourth and final video, the mean and variance of the uniform distribution. You met the uniform distribution in the first section of Discrete Random Variables. Here's an example of it for a fair die. In general, the discrete uniform distribution looks like this. Sometimes it's possible to derive general results for a distribution which are then quotable subsequently. One example of this is the discrete uniform distribution. In this distribution, each of a finite number of values has equal probability. We can derive general results for this distribution that we can then quote. You don't need to be able to prove these results, but they are not difficult and give useful practice in summing series, so you may want to pause the video and try for yourself before continuing to watch. OK. To find the mean and variance of a discrete random variable, you're going to need the sum of the values of xp and of x squared p. So, for all values of x, the probability is 1 over n. And then we multiply that probability by the value of x, 1 over n, 2 over n, 3 over n, and so on. And then multiply them by x squared, 1 over n, 4 over n, 9 over n, and so on. So the expected value of x is the sum of all the xp's. So that's 1 over n plus 2 over n plus 3 over n plus all the way up to n over n. I can take out a factor of 1 over n. And that gives me 1 over n multiplied by the triangular numbers. So that's 1 over n multiplied by a half n, n plus 1. And that simplifies to a half n plus 1. So that's the expected value of the uniform distribution. Again, finding the variance is a useful exercise in summing series, so if you haven't already done so, you may want to pause the video and work through this for yourself before checking the solution. So, the variance is the expected value of x squared minus the expected value of x all squared. So, using the figures we have above, that's 1 over n plus 2 squared over n plus 3 squared over n plus all the way up to n squared over n. I'll put that in brackets just for clarity, and from that we subtract the value that we just worked out, a half n plus 1 all squared. So if I take out a factor of 1 over n, that gives me 1 plus 2 squared plus 3 squared plus all the way up to n squared minus a quarter n plus 1 all squared. Now the sum of the squares is 1/6 n multiplied by n plus 1 to n plus 1. That's the result that I just had on a new slide for space. And I've got sixths and quarters, so I'll make those into twelfths so that I can subtract them. That n cancels with that n, and I've got n plus 1 2n plus 1 minus 3/12 n plus 1 all squared. So now taking out common factors of a 12th and n plus 1, I've got 2 lots of 2n plus 1 minus 3 lots of n plus 1. So that's 1/12 n plus 1 n minus 1, or 1/12 n squared minus 1. So here are the results, and remember that these results will be provided for you and may be quoted. Note that the expected value formula is the same as the standard formula for finding the position of the median for a list of values, which makes sense for a symmetrical distribution. Let's look at an example. This is the uniform distribution with n equals 8 as the die is fair, so we can calculate exactly from the derived results. So the expected value of x is n plus 1 over 2, and that is 9 over 2, which is 4.5. And the variance of x is n squared minus 1 over 12, which is 63 over 12, which is 5.25. We're asked for the standard deviation. So that's the square root of 5.25, which is 2.29 to 3 significant figures. That's the end of this video on the mean and variance of the uniform distribution, and the end of this section on geometric and uniform distributions.